In this video, let us study um, CDF PDFs of continuous random variable. The random variable is one which assigns the real numbers to the sample outcomes. So these random variables can be continuous or discrete or mixed type. So continuous random variable takes continuous range of values, while the discrete random variable takes the discrete sets of values. Mixed random variable can take the continuous range of values as well as discrete values. So in case of the continuous random variable, we need to study what is cumulative distribution function and probability density function. So with one example, we are going to see how the formulas are there for all these statistical parameters in case of the continuous random variable. So cumulative distribution function has the formula fxx is equal to probability x is less than or equal to x. So what is this x? Capital X is random variable, small x is the values taken by the random variable. So what is the PDF formula for this? PDF is nothing but the differentiation of the CDF. So if you want to find the PDF, so the notation is small f, subscript is capital F, x for the random variable, and small x is the values taken by the random variable. So in case of CDF there is capital F, and in case of PDF there is small f. So this is the differentiation of the CDF. So let us go deep into these formulas with one example, so that you will understand what these probability mean. Because we should know what is this set and how this probability come, and why this is called cumulative probability. So let us take one experiment, a random experiment where we are tossing two coins simultaneously, and we have to see how many heads are coming in the outcomes. So the sample space will be, if two coins are tossed simultaneously, then sample space will be HH. That means you will get head head or tail tail, or H head tail or tail head. So let us see how many heads are there in these outcomes. So that is the your x, random variable x. So it is 2 in first case, it is 0 in the second case, in third case it is 1, and it is 1 in the last case. So suppose you want to find the probability. In the CDF, you encounter with this term or with this probability. So suppose you want to find the probability x less than or equal to 1.5. So for that you need to find a subset. So what this subset includes? Subset includes all the outcomes whose random variables are less than or equal to 1.5. So the outcomes are TT, whose random variable is 0, HT, whose random variable outcome or random variable value is 1, and TH, whose random variable value is again 1. So this subset includes all the outcomes which are whose random values are less than or equal to 1.5. So uh, so so this is the x1 subset related to your desired outcome. So desired outcome is x is less than or equal to 1.5. So what is the probability of x is less than? So you understood now the set is this one. This set corresponds to probability x less than or this set is corresponding to x less than or equal to 1.5. Now what is the probability? So in this there are three outcomes and total outcomes are 4. So the probability is 3 by 4. So this term is nothing but the CDF. So fx we are going to write, and final is 1.5, or small x is 1.5, because your formula is fxx is equal to probability x less than or equal to x. So this x here is 1.5. That's why we are writing it as fx 1.5. So that is nothing but the 3 by 4, probability x less than or equal to 1.5. So let us see, if you want to find the probability x less than or equal to 2. So probability x less than or equal to 2 includes all the sample points. So subset is total samples points, and x1 are x1 all the random variable values are there. So here probability is equal to this number is 4 and total outcomes are also 4, so probability is equal to 1. So here in your random variable is defined as 0, has values 0 1 2. So maximum value of the random variable is 2, so we consider it as infinite. So we can write it as, because infinity is not defined, so in this set infinity is 2. So if you write as so this fx2 is probability x less than or equal to 2, we are getting it as a 1. So we can write it as, instead of 2 we can write it as infinity, and that value is coming as 1. So we can write one property of the cdf, that fx infinity is equal to 1. Fx infinity is equal to 1, or that is nothing but the probability of whole sample space. Let us take another property of the CDF. Suppose your x is we know in our case x is equal to 0 1 2. So minimum value of the x is minus 1. So minimum value is 0. Suppose you take it as a minus 1. The value beyond 0 is minus 1. Suppose you take it as minus 1, and if you find the CDF at minus 1, CDF at minus 1 is probability x less than or equal to minus 1. So in the random variable you have the value 0 1 2, but there is no value less than or equal to minus 1. That means there is no minus 2, minus 3, minus 4. So there is no value. So it the sample subset is null space. Subset is null space, so its probability is equal to 0. So if you consider, so fx minus 1 you are getting it as fx minus 1 you are getting it as 0. So if you consider minus 1 as a minus infinity, then fx minus infinity is equal to 0. So this is second property of the CDF, that CDF of the null space, or the if the subset contains no elements, then CDF of it is equal to 0. So what are the properties of the CDF? CDF is a probability, so its range is 1. And we have just now seen that fx infinity is equal to 1 and fx minus infinity is equal to 0. Graph of CDF is non-negative, as it is a probability, so it can't take the negative values, and it is non-decreasing. That means graph of CDF can be in continuous case, graph of CDF is continuous. So it is like this. It is increasing only, and it is constant, and it is continuous. So let us see how to find the probabilities if you have given the CDF graph. If you have given the CDF graph, then probability you can find by taking the difference between the two end points. Suppose if you want to find the probability at a point, probability x equal to a, then you can find fx a plus minus fx a minus. So what is a plus and a minus? Suppose this is the a value, then a plus is just higher than a, and a minus is just lower than a. But ideally, or we can say ideally, as a minus is equal to a is equal to a plus. And in case of the continuous random variable, a minus is equal to a plus. So probability at a point in case of the continuous random variable is equal to 0. If you want to find the probabilities in a range, then these are the formulas. So if you want if you want to find the probability a less than x less than or equal to b, then it is fx b plus, and point is b plus means higher than, somewhat higher than b, and a is fx of a plus. So accordingly, with this formula you can again find the formulas for the probabilities. Suppose a less than x less than b. So in this case, if there is equality, then b plus is there. There is no equality, so b minus. And there is inequality, then a plus is there. So inequality is there, so a plus is there. Suppose you want to find this, so here equality should be there, but it is not equality, so it is b minus. The reference you take this equation. Then here inequality should be there, but equality is there, so a minus in this case. Suppose here equality is required, so b plus is there. Inequality is required, so a minus is there. So our reference is this one, and the important point is you have to take the difference at the CDFs between the points where you between the range or between the endpoints of the range where you want to find the probability. Now let us see what is probability density function. Probability density function is notation is small f. This capital X is for the random variable, small x is for the values taken by the random variable. So PDF is nothing but the differentiation of the CDF. It is differentiation of the CDF, and CDF is integration minus infinity to x integration of the PDF. So what is the relation between PDF, CDF and probability? So this formula is very important. So CDF is nothing but the probability, you know, fxx is probability x less than or equal to x. Here I have taken it as minus infinity. So minus infinity less than x less than or equal to x is and it is nothing but the integration of the PDF. So minus infinity to x fxx dx. So this is very important. Now let us prove that area under PDF curve is unity and origin divides PDF curve into two halves. So we have just now seen that this CDF and this PDF is related like this. So here I have written the relation between CDF and PDF. This is CDF, this is PDF. So if you put x equal to infinity, here infinity is put. So in the integration also you have to put the infinity. So this is fx infinity minus infinity to infinity fxx dx. So this is area under PDF curve. This is area under PDF curve. If you take the PDF any graph value and take the integration over a whole range of x, then you will get the area under PDF curve. So this area under PDF curve, we know that fx infinity is equal to 1. Fx infinity is equal to 1. So area under PDF curve is equal to 1, because this is area and this value is equal to 1. Now as area under PDF curve is equal to 1, and you know that uh, odd function has area is equal to 0. Area is equal to 0. So odd function has area is equal to 0. So we can say that the PDF cannot be odd function. It should be even function because its area is not equal to 0. So instead of this we can write it as, if even function is there, we can write it at 2 into 0 to infinity fxx dx is equal to 1. So here written, so 0 to infinity fxx ds is equal to 0.5. That means area of the PDF curve after origin is equal to 0.5 and before origin is equal to 0.5. That means origin divides this PDF curve into two halves. So we have seen that PDF area under PDF curve, this total area is equal to 1, and a PDF is a even function. That's why area before origin and area after origin is half of the total area, that is 1 by 2. So how to calculate the probability with if you have given the PDF graph, then probability you can find with integration, and limit is again here a plus is there and b plus is there, and limit is you have to take the integration, and this is the PDF graph. Again as just as we have seen in the CDF, if there is a equality then a plus is there, b plus is there. If there is inequality, then a plus is there. In this case there is no equality, so b minus, and here inequality, so a plus. Let us see this one. Here inequality is required, which is not there, so b minus. Here equality inequality is required, but it is equality, so it is a minus. That means you have to compare this. If at the b there is equality, then b plus, and at a if there is inequality, then a plus. If reverse is there, you make it as a minus and b minus. For example, here equality is there, so b plus. Here equality is there, so a minus, because at a you required inequality. So these are the formula, and let us find the probability at a point. So for that you have to take, so here it should be a plus, sorry, it should be a plus, it should be a minus. A minus a plus fxx dx is equal to 0. So a plus and a minus are same in case of continuous random variable, because continuous probability density function is continuous in nature. There are no step changes. That's why a plus and a minus are same, so the integration becomes 0. So probability at a point in case of continuous random variable is equal to 0. So hope you understood all the concepts in case of the continuous random variable.